Okay, welcome back, everybody. Hope you were able to completely finish the homework assignment, and you're here just to sort of check to see if how you did it was one of the right ways, because there's usually more than one way, and to check your answers. All right, so again, this is the final part of the CPM 2.1.2. If you're using the actual textbook and not the CPM ebook, it is page 61. But whether you're using the ebook or the textbook, it is this lesson, right? 2.1.2. Okay, talk about how else can we represent data. Okay. So we went through 2-15 and 2-16, and we left off at the beginning of 2-17. Okay, so as I read the question, you can read in your book as I read, just sort of make sure that I'm getting all the words right. It's just good for you. Maria was putting together party favors, that's small bags of treats for each person, for her niece's birthday party. In each bag, she put in 3 small chocolate candies and 4 hard candies. If Maria had 12 bags, how many candies did she use in all? And how can you represent this with a numerical expression? Okay, so I'm talking about 12 bags, and each bag, I'm just going to draw a bag. Let's draw the bag and just make it like a U. Okay, and let me see, there were in each bag 3, right? If this was a piece of paper I can write on, I might circle that word 3 and circle the word 4. Okay, just to sort of, if this is a test I can write on. So 3 and 4. I got 3 chocolate. So I'm going to put 3 CH and 4 hard candies. So I'm going to put 4 H. Okay, that's one bag. Another bag is going to have 3 chocolate and 4 hard candies. Another bag is going to have 3 chocolate and 4 hard candies. Okay, I'm putting H for the hard. Now I can do this 12 times. Okay, but at that point, I know I'm going to have 12 of these threes, huh? Okay, 12 of those threes for the chocolate. So I'm going to have 12 bags of 3 chocolates. Okay. And I'm going to also have 12 bags of 4, and that's a time sign, of the hard candies. Okay, so 12 times 3, I'm going to have a total of 36 chocolates. I'm just going to write choco there. And I'm going to have 12 times 4, that's 4 tens, is 40. And 4 twos is 8. So 40 and 8 is 48 hard candies. And I'm going to say 48 plus 36 is a total of 84 pieces of candy. Okay, so the first question, how many candies did she use in all? Yeah, that's 84. Now, can I write that as a numerical expression? Well, let's see what we did here. Each bag had 3 chocolate and 4 hard candies, or 7. I had 12 bags of 7. 7 times 12 is also 84. But is there another way of writing that? All right. We separated the chocolate and the hard candies, but all they really want to know is how much candy each person got. Chocolate is also candy, right? So really they had 12 bags, and each bag, and that word each in math oftentimes means you're going to multiply. Okay. Each bag had 3 plus 4 pieces of candy. Okay. So if I do 12 times this total of 3 plus 4, I'm doing 12 times 7 equals 84. This looks like an expression for how much candy was used. All right. Now, if I put an equal sign, 84, it's no longer an expression, it's now an equation. An expression does not have an equal sign. An equation does. And because equation and equal all start with the EQUA, hopefully that helps you remember. Okay? And an expression could be 3 plus 4. It could be 6 minus 2. It could be 124 divided by 2.5. That's an expression. It could be 4 times A minus 2 times N. That's an expression. Okay? We have an expression right there. 84 pieces. I'm going to put a big box around all my work for 217. And again, little box around that answer, little box around the other. Go to the next one, 2-18. And now it says, how many different rectangles can you draw with an area of 28? Okay, well, 28. I can draw a long, skinny rectangle. That's 1 by 28. That's going to have an area of 1 times 28. It's 28. I can draw another rectangle that's a little bit wider, maybe twice as wide, and half the length. That's 2 by 14. 2 times 14 is 28. Now, I can't have a rectangle with 28 total tiles that has a 3 in there as one of the sides, right? Okay. But I can with a 4, right? I could say if it's 4 by 7, that would be a rectangle that has 28 total tiles, okay? Now, can I do any more? I don't think so. I think that's it. I mean, I could do one like this that's flipped up on its end and have 1 wide and 28 tall. And same here, I could have 2 wide and 14 tall. But it's kind of the same rectangle, right? Just sort of turn. Next question is, what is the perimeter? And they say toothpicks, and that's from that worksheet where we had these were the tiles, right? I had some red ones, and toothpicks were each edge. Toothpicks are about the same size. And it's this idea of showing you a perimeter and area. So what would the perimeter be? 4 plus 7 plus another 4 plus another 7, or 4 and 7 is 11 doubled. The perimeter of this equals 22. 2 plus 14 plus 2 plus 14, or 16 doubled. The perimeter of this is 32. 1 plus 29 plus 1 plus 20, 1 plus 28 plus 1 plus 28, or 29 doubled. And that equals 58. So the perimeter of this one is 58, this one's 32, this is 22. And you'll find the closer you get to the square, for the same area, the less fence you got to buy. The smaller the perimeter is. Okay? All right, on to 2-19. Before I do that, let's put a big box around all my work there. Maybe a little box around the 3 perimeters. All right, 219. Miss Katz paid $50 for a used bicycle, and then she sold it to her neighbor for $60. She decided to buy it back, but now the neighbor said, "No, you got to pay me $70," and she did, and then she sold it again for $80. How much money did she make or lose overall? Well, first she spent $50, right? But then she got $60. So far, she's got an extra $10, huh? But then she went and spent 70. Spent 70, and then she sold it for 80. So she got another $10. Now, she got an extra 10 here, an extra 10 here. So far, she has an extra $20. Sounds like to me, huh? But she doesn't have a bike. But if she could find someone to sell a bike for $50 like that first one, she already got 20. It's only going to be how much extra? 30. Yeah. All right. That's one of those hard questions. I kind of made it look easy, hopefully not too easy. But yeah, just take it in steps. right, on that one. All right, good job on the homework. Hopefully you completed it on time and you're just checking answers on Tuesday. Uh, yeah, I did this on Monday for you. Uh, and hopefully you're getting full credit because you turned it in on time. Otherwise, hey, better late and missing a couple points, but understanding the whole thing, right? Okay, that'll be the plan from now on.